Continue our discussion on limits and continuity, part B here. So we mentioned last time that we could have a limit if the function was defined. We could have a limit if there was 0 over 0 in the function, and we could factor it and come up with a real number. But now what about this situation? Okay, if we have a number over 0, or if we have the square root of 0, or absolute value of 0 over 0, or 0 over the absolute value of 0, or a piecewise function, we're going to have to use what are called right and left-hand limits. What are right and left-hand limits? So a left-hand limit. For example, if I have limit as x approaches 0 of x plus 1 over x, well, if I plug in 0 for x, it's 1 over 0. So this is one of the situations that we have now. To take a left-hand limit, you do the following. Limit as x approaches 0 from the left-hand side. That's why it's got the negative there. Of x plus 1 over x is equal to 1 over, now, as it approaches from the left-hand side, this is not, negative 0 really isn't a number, but it's a number that's a very, very tiny number, but it's going to be from the left-hand side, so it's going to be negative. So as the numerator approaches 1 and the denominator approaches 0 from the negative side, this is going to approach negative infinity. So if we were to graph that, it would go all the way down on the range. So remember that a left-hand limit, we place the little negative sign after the number for the limit. So this is x as it approaches 0 from the left-hand side. So the right-hand side, as you might guess, well, I've got a little plus sign there as we approach 0 from the right-hand side. So the same example here, x plus 1 over x, well, now we have 1 over a very, 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 very small positive number, okay? So it's going to approach positive infinity. So we're not done yet. We have to look to see if we can find a final limit. Well, we said that as it approaches 0 from the left-hand side, the final answer was, oh, if the two equal each other, then the final answer is whatever that limit is. If they don't equal each other, then the limit does not exist. So for the problem we just did, as it approached from the left-hand side, our answer was negative infinity. As it approached from the right-hand side, it was positive infinity. So those are not equal. So for this, the limit as x approaches 0, in general, it doesn't exist because we don't know if we're approaching from the left-hand or right-hand side. They would have to be equal in order for this to have a single limit. So one single limit does not exist. Let's take a look at another example here. So I've got the limit as x approaches 1 of the square root of x squared minus 1. Well, that equals the square root of 0, which is 0, but this is a little tricky because we have to look at both the left and right-hand limits. So for the left-hand limit, as x approaches 1 from the negative side, 1 squared, okay, is going to be just slightly less than 1. So a number that's slightly less than 1 minus 1 is going to be a number that's just slightly less than 0. And we can't have a negative square root. So the limit, the left-hand limit, does not exist. Now the right-hand limit, as we approach 1 from the positive side, well, that number is a very, very small positive number, a very, very small number greater than 1. And subtracting 1 is going to be a very, very small positive number. So that is going to be a valid limit. But since the two limits don't match, it does not exist from the left-hand side, it's equal to 0 from the right-hand side, there is no overall limit. There is no one single limit for our original equation. What about something like this? limit as x approaches 1 of the absolute value of 1 minus x all over 1 minus x. Well, here we have we plugged in 1 for x, we'd have the absolute value of 0 over 0, another left and right hand limit. So let's take a look. As we approach x from the positive direction, okay, we're going to have a positive answer. But remember, the issue here is that at no point can you ever have a 0 in the denominator and claim that that fraction equals a number. So we have to do a little bit more thinking about it rather than just plugging in 1 for x there. So let's take a look at what happens if we plug in a number just slightly smaller than 1. So we're approaching from the left-hand side. Well, if we use a number like 0.9999, well, we have 1 minus 0.999, the absolute value of that, divided by 1 minus 0.9999, which is 0.1001. Well, that definitely equals 1. In fact, no matter what we pick for x, we will always get 1 as long as the values for x are less than 1. So our left-hand limit as we approach x from the left-hand side is equal to 1. But what happens when we look at the right-hand side? So let's look at a number that's just slightly greater than 1, like 1.00001. Okay. If I look at my numerator here, it's going to be just slightly less than 1, but I'm taking the absolute value, so it's a positive 0.0001 divided by a very small negative 0.001. So as we approach 1 from the positive side, my output is negative 1. Remember, our left-hand limit was a positive 1. Our right-hand limit is a negative 1. So in this case, our overall limit does not exist. So let's take a look at one more example here. I've got the limit as x approaches 0 of 1 divided by x squared. Well, if I plugged in 0 for x, that would give us 1 over 0. So we have to look at left and right-hand limits. So the limit as x approaches 0 from the negative side, 1 over x squared. Well, x squared is going to be a positive number no matter how small it is. Even if x is negative, then x squared is going to be positive. So 1 over a very, very small positive number is going to be positive infinity. Now, as we approach 0 from the positive side, x is still going to be positive, and x squared is going to still be positive. So 1 over positive 0, as it gets closer and closer to 0, it's going to approach positive infinity. So since the left-hand limit does equal the right-hand limit in this case, we can say that the overall limit as x approaches 0 for 1 over x squared is indeed positive infinity. So let's summarize from where we were yesterday or previous class. So as we're taking a limit, try plugging in the number. If you get a real number, well, then that's your answer. If you get 0 over 0, try to factor the original equation, simplify, and plug in again. If you get a real number this time, that is your limit. Now, if you get one of these that we've looked at today, we have to look at it as it approaches the left and right hand limits from both the left hand side and the right hand side. If those, then that is your answer. If they don't match, then your answer is simply does not exist. Okay, so I'm going to switch over now to the in-class worksheet, and we will stop here for this lesson.